Hey guys, I'm here to do lesson 7.6 with you. Your learning target for today's lesson is I will be able to write one-step equations. So we're going to kind of take it back a little bit to Unit 6. Remember when we were writing equations for verbal phrases? We're going to start doing that, but we're going to solve them because they're going to be equations instead of expressions this time. So your think about it says, Matthew's teacher wrote the description on the board. The sum of a number, n, and 15 is 32. Create a bar model that represents the description. Write an equation that represents the description. And then explain how creating the bar model helped you write an equation. So go ahead and pause the video and see if you can do the think about it on your own. Alright guys, we're back to do the think about it. So the first thing I want to do is I'm going to mark up my text. So it says the sum, so that means I'm adding, of a number, so that's one part, and 15, that's my other part, so these are parts, and then 32 is going to be my total. I know that 32 is my total because when I see the word is represents your equal sign in the equation. So now that we know what our total and our parts are, we can go ahead and draw a model from that. So let's go ahead and do that. Our total equals 32. And then we have two different parts. We have one part is going to be n, and then the other part is going to be 15. So I draw my second model, break it up into two parts, label one n and the other 15. So there's our model. We've finished with part A. Part B says write an equation that represents the description. So we need to be careful. We're not writing an equation that represents the variable, which is what we've been doing. We want to write a description that represents this phrase. Okay, so if we're adding, if it's talking about the sum, we know that we're adding, and then our two parts are n and 15. So that means we must be adding n plus 15, and then our total is 32. All right, so step C, part C says explain how creating the bar model helped you write an equation. So the first thing I did was I determined the total after marking up my text, of course. I determined total was 32. I drew one bar model, labeled 32. Then I drew an equal-sized bar model. And broke that into two parts. N and 15. Okay, and then I knew that we needed to add because of the word sum. Key point for today's lesson says creating a bar model helps translate mathematical descriptions to equations. So let's start with the interaction with new material example number 1. It says write an equation that represents 5 less than some number is 20. Okay, first thing I'm going to do is I'm going to start by marking up my text. So we have 5 less than. So it looks like we're going to be 5. We're subtracting 5 because less than tells me subtract. And how much am I going to subtract? 5. 5 less than. Be careful you don't do 5 minus, because that's saying that we're starting with 5 and then we're subtracting some number. But this phrase right here says we're starting with some number and then subtracting 5. So we have, again, some number, which is going to be a variable, n, is equals, or is represents an equal sign, and then it's going to equal 20. Now notice I did not write that one as my total this time, and it's because since we have less than, we are going to have to subtract. And remember, when we subtract, we have to be careful about what number we select as the total. So the number that we start with is our total. Okay, since we're taking 5 away from a number, we're not starting with 5, we're starting with a number. So in that case, our total is going to be our variable, which is that number, n. So I'm going to draw my bar model to represent the total and label it with an n. Okay, I'm working with a subtraction problem, so I am going to have 2 different parts. So one part is going to be our equals 20, so 20 is going to be one of the parts. Whoa. And then the other part is going to equal 5. Because we're using our 5 and we're using the 20. Okay, so I break it into 2 parts. Oh, I probably should draw it a little bit more accurate. Okay, one part is 20 and one part is 5. So again, 20 and 5 represent the parts, and n represents our total. Since we don't know our total, we're not going to subtract. We know both of our parts. So when you know both of your parts, that's when you're going to use addition. So we're going to add our parts together. So 20 plus 5 equals n. So when we simplify that, 20 plus 5 is 25. So n equals 25, and we can check our work by plugging it in to a number sentence that we now have to make sure we create from this phrase. So again, because it says is 20, that means we want our equal sign and 20 to be at the end. Because it's saying, when it says is 20, it's saying the answer is 20. So we want to make sure we put our 20 on the on one side of the equal sign. And then again, we're starting with n and we're taking away 5. So this should be the expression that represents the phrase from example number 1. Now we can plug in our variable n, 25, into this expression and see if we get 20 as the answer. And if we do, we did it correctly. So 20 minus 5 equals 20. When I simplify, 25 minus 5 is 20, and 20 equals 20, so we are correct. All right, so let's move on to example 2. Example 2 says, write an equation that represents the quotient of 25 and a number is 10. So let's mark up our text. We have the quotient. Quotient means the answer to a division problem of 25. Remember, the first number they say after a quotient is going to be your dividend. And a number, so this is going to be n, will be your divisor. And then it's saying your quotient is 10, so it's going to equal 10. So again, because this is a division problem, we have to be careful about our total. Our total is always our dividend. which in this case is going to be 25. So total equals 25. Now since we're working with a division problem, we're going to have number of groups and group size this time. So number of groups equals, and we always want our variable to be the number of groups. So our number of groups is going to be n. And that means the only number we haven't used yet is 10. So our group size equals 10. So let's get this all drawn out. We have our total bar. This represents 25. Okay, we draw one box to represent the group n, and then draw an arrow to the end and label it with n, and then our group size goes in that box. So 10 is inside the box. Okay, now to solve for our variable, since we know our total and our group size, that means we're going to have to divide to solve. Anytime we're given our total, we're going to have to divide to solve for variable. So we're going to take our total, 25, and we're going to divide it by our group size, 10. And that's going to give us our variable, n. Okay, so when we divide this, 25 divided by 10, I end up getting 2.5 as n. So to see if we're correct, we're going to try to write an expression from our phrase and then plug in 2.5 to see if it works. Okay, we know that our total is going to be, or we know our total, so that means our divisor is going to be 25. So that needs to be at the very top of my fraction. And then we're dividing by, or I need to make sure that 10 is the answer, right? So 10 is going to be my quotient at the end. So I've used 10, I've used 25. The only thing left for me to use is our number, n. So I'm going to divide by n. So let's plug in 2.5 and check our work and see if it works. So we have 25 divided by 2.5 equals 10. So when you divide 25 divided by 2.5, I do get 10 as the answer. So 2.5 equals n is our correct answer. And we helped, and we used this bar model to help us, and then we used some of our previous skills that we learned about writing expressions to help us solve these problems. All right, guys, well, that's it for today. If you have any questions, I will see you during our Zoom meeting. You might want to have your list of keywords with you if you ever made that poster for extra credit a couple of weeks back when it was closer to the beginning of distance learning. If not, I will try to post one in the Google Classroom so that you have keywords to look for in order to help you determine operations. All right, guys, well, I hope you have a good day. We will talk to you